Hello everyone. Today in this session we will be dealing with the lattice structure for FIR and lattice ladder structure for IIR filter systems. FIR lattice structure. Here in this we'll be looking at the formula and the structure to draw the lattice structure. So here we have few formulas, that is Km is equal to Am of M. In order to calculate the value of M, it is M is equal to capital M comma I minus 1 till 2 and 1. And here it is Am minus 1 of I. In order to calculate the value of I, it's I is equal to 1 comma 2 till M minus 1. And accordingly we have to draw the structure. So this will be the structure for first stage from this point to this point. Again there's a second stage from here to here. Right. So let's start with the problem. Let's start with an example. Determine the Km coefficient of the lattice corresponding to FIR filter described by the system function and also draw the lattice structure. So this is the transfer function. H of z is equal to 1 plus 2 of z is to minus 1 plus 1 by 3 z is to minus 2. Here in FIR it is all 0 systems. Now as the order of the transfer function is 2, so it is a2 of 1 and a2 of 2. So this value is a2 of 1, a2 of 2. Since we have two zeros in h of z, we take the value of capital M as 2. So by using these formulas, we'll be calculating the value of Km and Am plus 1 minus I. Let's see. Here the value of M is equal to 2 and the value of I can be calculated by this formula, therefore I becomes 1. So substitute the value of M is equal to 2 and the value of I in these two expressions. We get K2 is equal to A2 of 2, which is 1 by 3 by the transfer function, and like in this equation I'll get A1 of 1, which is equal to A2 of 1 minus A2 of 2 into A2 of 1 divided by 1 minus K2 square. So by substituting the value of A2 of 1 as 2 and A2 of 2 as 1 by 3 and the value of K2 as 1 by 3, we get the answer as 3 by 2. Now we need to calculate for M is equal to 1. Right. So here K1 equal to A1 of 1, which is 3 by 2, which is already calculated in this session. But we will not be able to calculate Am minus 1 of I. Right. So here we will be starting with structure of FIR lattice. Now this is the first 2 points. This is the input x of n. There is one delay. You will be giving 2 adders, and this is the value of K1. Now a similar kind of structure has to be drawn for the K2. Again you will be drawing one delay, 2 adders with x mark and the answer. This is your y of n. R2 of n is not necessary, but this is the structure how you can draw it for FIR lattice. Let's look at another problem. Given the FIR filter with difference equation, sketch the lattice structure. So this is your difference equation now. Now you can see, you can just try to understand there are no y terms, there are only x terms here. So in FIR we have only 0 systems, right? So now you're going to take the z transform on both the sides as usual, and we get h of z as 1 plus 3.1 z minus 1 plus 5.5 z raised to minus 2 plus 4.2 z raised to minus 3 plus 2.3 z raised to minus 4. So as the order is 4, this is nothing but a4 of 1. This is a4 of 1, this is a4 of 2, a4 of 3, a4 of 4. Since we have 4 zeros in h of z, we take the value of m as 4. Again we have to use the same formula again. Let's for m is equal to 4, right? So we'll be calculating m is equal to 4, 3, 2, 1. So initially for m is equal to 4. Now what will be the value of I? Substitute the value of 4, we'll get I as 1, 2, 3. So we'll get I is equal to 1, I equal to 2, I equal to 3. So in the formula of Km and Am minus 1 of I, so if I substitute I is equal to 1, so as it is, it will become Km equal to Am of M, that is K4 equal to A4 of A4, A4 of 4. So A4 of 4 is 2.3. Now here it was Am minus 1 of I, so value of M is 4 here, so it will become A3, and as it is 4 minus 1 3, so A3 of 1. Now substitute the value of M over here, keep I as it is. Now again you can substitute the I value later also, that is not an issue. So A4 of 1 minus A4 of 4, A4 of 3, again this expression, substitute the value of A4 of 1 which is 3.1, A4 of 4 as 2.3, A4 of 3 as 4.2, and A4 of 4 as 2.3 square, which is nothing but your K4. We get 1.529. Now for the same value of M is equal to 4, we need to calculate for I equal to 2, right? So A3 will remain the same for M is equal to 4, as it is Am minus 1 of I. So it is A3 of 2 now. A3 of 2, this will become A4 of 2 minus A4 of 4 into A4 of 4 minus 2, which will become 2. Again K4 is as it is. So A4 of 2 is 5.5, A4 of 4 is 2.3, A4 of 2 is 5.5, and the value of K4 is nothing but 2.3 square. Similarly, you are going to calculate for I equal to 3. So again the A3 will remain the same, go on substituting value of I, and you get the answer as 0.683. Now in the similar way, you will be calculating M is equal to 3, M is equal to 2, M is equal to 1. And you will be referring A3 of 1, A3 of 2, A3 of 3 for the further calculation. Now for M is equal to 3 and I is equal to 1, 2, I minus 1, then the value of I becomes 1 and 2 only. So here for M is equal to 3, the value of I is 1 and 2. So this is the formula here, which is Km is equal to Am of M, and Am minus I is equal to Am of I minus Am of M into Am of M minus I divided by 1 minus Km square. So looking at the formula, you just need to substitute the value of M as 3 and I as 1 and 2. So this is K3 equal to A3 of 3, which is 0.683 from the previous answer where we find this in M is equal to 4. Now A2 of I. So as the value of M is 3, so it is Am minus 1. So it is A3 minus 1, that will become A2 of I. Now this is A3 of I minus Am of M is nothing but A3 of 3, as value of M is 3. A3 of 3 minus I, 1 minus K3 of square. So value of K3 is nothing but 0.683. Now we need to substitute for I is equal to 1 and 2. So it is A2 of 1, A3 of 1 minus A3 of 3, A3 of 2. Why? The 3 minus 2 is nothing but 1. 3 minus 1 is 2 divided by 1 minus K3 square. Substitute the values. You will get these values from the values where you have found in M is equal to 4. So you need to collect the values. So the value of A3 of 1 is 1.529, value of A3 of 3 is 0.683, value of A3 of 2 is 1.667, and the value of K3 is 0.683. You will get answer as 0.732. Similarly, substitute the value of I is equal to 2 in this equation. You get this answer, referring to the value of A3 of 1, A3 of 2, and A3 of 3. Now again, taking these values as A3 of 1, A3 of 2, and A3 of 3, will be calculating for M is. So for M is equal to 2, so we get I as 1. So it is K2 of A2 of 2, which is 1.167 from the previous M is equal to 1. We can see it here. So A1 of I. So as the value of M is 2, so Am minus 1. So it is 2 minus 1 becomes A1 of I. So again the same answers, same substitution. Only thing that we will be calculating for I is equal to 1 now. So after this, we have the value of a2 of 1, a2 of 2, and a2 of 1. Substitute these values and you will get answer as 0.338. Now for m is equal to 1, we don't have the value of I. So it is just k1 equal to a1 of 1, which is 0.338, which is this. So we have 4 k values, k1, k2, k3, k4. So this is k1, k2, k3, k4. So this is the first structure of k1. This is the second of k2. Again the same structure for k3 with one delay and two adders for each of k1, k2, k3 and k4. IIR lattice ladder structure. So the lattice realization of IR filter is obtained by first realizing the lattice structure for on pole filter, then inserting the appropriate multipliers and adders to realize the zeros. So here we'll be trying to analyze only the poles when you're considering lattice realization. So here for each of the k terms we are trying to draw two adders and one delay. Now let us consider the pole and zero system having a transfer function given by h of z is equal to zeros by poles, so which we have seen in third form 1, 2 and cascade parallel. So here this numerator is represented by b of z and the denominator is represented by a of z, where 1 by az is pole filter, b by z is a zero filter. So here we'll be calculating first 1 by the pole filter, then we'll be cascading with that with respect to zero filter. So again we'll be calculating using the same formula to calculate the value of km and am minus 1. Then we will be also trying to calculate the value of bm I minus bi. So these are the two formulas which you need to remember for further calculation. And this is the structure which is belonging to lattice ladder structure of an IR filter. So this will be your poles term, this will be your zero term. So how do we calculate zero? We'll see by few examples. Now realize the IR filter transfer function using the following lattice ladder. So as the numerator and the denominator is having the same power, that is 3, 3, right? So the numerator is 0 and the denominator is pole. So 1 by az is nothing but this term. So az is this. Az is the denominator. So under az, this is, as the value of power is 3, so this will become e3 of 1, e3 of 2, e3 of 3. And this is 0. So this is a numerator, which is b of z. This will be b0, b1, b2 and b3 as shown here. By basically using the same formula of km and am minus 1 of I, we'll be calculating the poles here. So since there are 3 poles in h of z, as we have discussed in both the numerator and the denominator are having the same power. So for m is equal to 3, k3 is equal to e3 of 3, which becomes minus 0.0276, which is the value of e3 of 3. Now the value of I is calculated by this formula and we get I as 1 and 2. So here for m is equal to 3, we need to calculate for I is equal to 1 and I is equal to 2. So looking at this formula, am minus 1, so it is a3 minus 1, we get a2 of I, a3 of I minus a3 of 3 into a3 of 3 minus I divided by 1 minus k3 square. Now substitute the value of I as 1. So it is a2 of 1, a3 of 1, a3 of 3, a3 of 3 minus 1 it is. So it is a3 of 2. And this is as it is 1 minus k3 square. Substitute the value of these and you will get the answer as minus 0.2875. Now for I is equal to 2. So it is a2 of 2, a3 of 2 into a3 of 3 into a3 of 1 divided by 1 minus k3 square. Again these values will be found from the transfer function. And this is the answer, 0.3485. Now for m is equal to 2. How do we calculate for m is equal to 2? Now in order to calculate I, this is the formula and we get the value of I as 1. So here under m is equal to 2, we will be calculating I is equal to 1 only. So it is Km is equal to AM. So K2 is equal to A2 of 2 is nothing but 0.3485, which we have calculated here. Now this is AM minus 1. So this is A2 minus 1 of I. So it will become A1 of I. This is A2 of I minus A2 of 2 into A2 of M minus I. M is nothing but 2. So 2 minus I will become 1. So here, go on substituting the value of I, you will get this expression. And the value of A2 of 1, which we have calculated for under M is equal to 4, is minus 0.02875. So we have the value of A2 of 1 as minus 0.2875 and the value of A2 of 2 as 0.3485. We get the answer as minus 0.2132. Now for M is equal to 1. So for M is equal to 1, the value of I becomes 0. So Km is equal to Am of n. So K1 is equal to A1 of 1, which is nothing but A1 of 1 is nothing but minus 0.2132. So this is what we have calculated the poles. Now we'll be calculating the zeros. So in order to calculate the zeros, this is the formula. So this you need to remember. Since we have 3 zeros in H of Z, we take the value of M as 3. Therefore, I is equal to 3, 2, 1, 0. So the value of I has to be calculated from 3 to 1, 0. Right. Now, for I is equal to 3, as the value of M is 3 and we will be starting with I is equal to 3. So, beta is nothing but beta 3 equal to bi is nothing but b3 minus summation of M is equal to I plus 1 to M. So the value of I is 3. So if I substitute I as 3, I get M is equal to 4 is to 3. Wherein I am keeping beta M and AM as it is, and this term will become 0. Right. So if I expand this summation term, I get beta 3 of A3 of 0 minus B4 of A4 of 1, wherein I don't have the value of A3 of 0 and A4 of 1. So this part will become 0. And you get the answer as B3 as 0.129, which is there in transfer function. So the value of B3, B2, B1, B0 will be found in the transfer function. And the remaining values of A's will be found from the calculation of M is equal to 4, 3, 2, 1. Now we'll be calculating I is equal to 2. Now here, so it is beta I is nothing but B2 equal to Bi is nothing but B2 minus summation M is equal to I value is 2 now. So 2 plus 1 till 3. So summation of M equal to 3 to 3 into beta M is B3 into A3 minus M minus I. So here we get B2 minus, we are going to expand this term now. So this is B3 A3. Now 3 minus 2. So we'll be starting with 3 only. Right. So it is 3 minus 2. The value of M is 3. Value of I is 2. So we get A3 of 1. Right. Because the value of M is ranging from 3 to 3 only. Substitute the value of B2, which is 0.03869 from the transfer function. The value of beta 3 is 0.129 and the value of A3 of 1, which we have calculated under M is equal to 4, and we get the answer as 0.4252. Now we'll be trying to calculate I is equal to 1. So beta 1 equal to B1 minus summation of I is 1. So it is M is equal to 2 to 3. Beta M AM minus M minus I. So B1 minus, so value of M is going to range from 2 to 3. So it is B2 A2 M minus I. So the value of M is 2 here. 2 minus 1. Why? M is starting from 2. You should look at this value and substitute over here, not the initial value, that is M is 3. So it is 2 minus 1. We get A2 of 1. Next, beta 3 into A3 into 3 minus 1. So we get A3 of 2. Substitute these values and we get this answer. Similarly, we will be calculating I is equal to 0. So it is beta 0 equal to B naught minus summation. I is 0 now. So the value of M is going to range from 1 to 3. As the order of the 0 is 3 only, right? Now beta M, AM into M minus I. So we get, so the value of M is going to range from 1 to 3. So beta 1, A1. Now this is 1 minus 0. Here beta 2, A2 into 2 minus 0 minus beta 3, A3 into 3 minus 0. So B naught minus B1, beta 1, A1 of 1 minus B2, A2 of 2 minus B3, A3 of 3. Substitute these values and you get the answer for I equal to 0. So this is the structure for lattice ladder IR filter now. So this is the upper term, the K represents the poles and the beta represents the zeros. So for each K term, we have 2 adders and 1 delay. So this is my K3, this belongs to K2 and this belongs to K1, right? And we'll be drawing the zeros now. So after each adder, we'll be giving one beta value. So this is B naught initial, this is beta 1, beta 2, beta 3. So we need to add together. So beta 3 plus B naught, beta 2 plus beta 1 plus B naught, which gives you the answer as Y of n. So this is how we have to draw the structure for IR lattice ladder structure and mention all the values of K and beta. Thank you.